NASA spacecraft flying record-setting formation. Presented by Science at NASA. Summertime air shows are fun to watch, especially when aircraft fly in tight formation. The sight of airplanes soaring overhead practically wingtip to wingtip is thrilling to behold. 4 of NASA's spacecraft recently performed an equally thrilling maneuver. In October 2015, the satellites of NASA's Magnetospheric Multiscale or MMS mission gathered into a tetrahedral formation with each spacecraft at the tip of a 4-sided pyramid only 6 miles across. Moving together as one, they raced around Earth at 15,000 miles per hour. Conrad Schiff, MMS orbital dynamicist at NASA's Goddard Space Flight Center in Greenville, Maryland, says, "No other multi-spacecraft formation has flown this close." The purpose of the maneuver was to study the inner workings of magnetic reconnection, sometimes called the universe's favorite way of making things explode. Magnetic reconnection can happen anywhere magnetic fields permeate space. Magnetic lines of force cross, cancel, reconnect, and in a sudden explosion, magnetic energy is unleashed in the form of heat and charged particles, racing away in all directions. This process is linked to a wide range of explosions from flares on the Sun to massive eruptions in the cores of active galaxies. It also happens in Earth's magnetic field. Not far above our own planet, small-scale magnetic reconnection sparks geomagnetic storms, disturbances of Earth's magnetosphere that, among other effects, can trigger aurora. MMS was launched in March 2015 to study the process at close range. By studying it close to home, we can better understand it throughout the universe. John Dorelli, a member of the MMS science team at the Goddard Space Flight Center, explains, "To understand magnetic reconnection, we have to measure thin layers of fast-moving electrically charged material called current sheets that are typically 6 miles or less in thickness. That is why the spacecraft had to fly in such tight formation. Down on Earth, airplanes can fly much closer together than that, but they have a big advantage over MMS. Schiff says, "First, aircraft flying in formation above Earth enjoy the control afforded by the atmosphere, that is, lift and drag. These forces are akin to the friction that allows your car's tires to grip the road. Spacecraft do not ever feel these forces. A highway analogy will be driving on ice. Under these frictionless conditions, you always allow far more space between yourself and other drivers." Second, says Schiff, the pilot in an aircraft is always able to see the other planes, visually and via instrumentation. In space, the spacecraft can see each other. They require much more sophisticated instrumentation to know where the others are. MMS solves the formation problem in part using its navigator system. Schiff says the navigator uses GPS signals and a model of the orbital dynamics so that each spacecraft knows where it is at all times. Each spacecraft also has an acceleration measurement and control system. Schiff explains that this system carefully measures the output of the onboard thrusters and either steps on the pedal or steps on the brake to ensure that control is maintained. Cutting-edge computer software called the Formation Design and Control algorithm helps too. Schiff says it analyzes the dynamics of MMS and finds orbits where the spacecraft can safely gather in pyramid form. 6 miles set a record, but it was only the beginning. Tom Moore, the MMS project scientist at the Goddard Space Flight Center, says, "As of September 2016, we have gotten the formation down to 4.5 miles. A tighter formation will give us the key data from what's called the electron dissipation region of the reconnection zone." Rarely has space physics been so thrilling. For more about MMS, visit www.nasa.gov/MMS. For updates from the reconnection zone, stay tuned to science.nasa.gov.